Rhede, Germany. Since 1752, the Wenning family has run a successful agricultural business and distillery. 30 years ago, they took the first pioneering steps towards on-site biogas production. Today, the company has evolved into an award-winning energy producer. The energy cycle simply works like this. The distillery contributes with residues that feed the bulls. The bulls give manure in return, a raw material for the biogas plant. The plant produces gas which is converted to green gas and used to generate electricity and steam. This is a closed loop with lots of advantages. By 2020, 20% of all energy and 10% of all transport fuel should come from renewable sources. To reach these European targets, countries are rethinking their energy mix. While abandoning its nuclear program, Germany is at the forefront of promoting biogas as an alternative power source. As methane emissions from excesses of animal manure are a much bigger threat for the atmosphere than CO2, converting these gases by anaerobic digestion is a great answer to the ecological challenges. In Germany, over 6,000 anaerobic digesters convert biomass into raw biogas, which can be used to produce electricity or heat locally. This number will more than double over the next 10 years. Since the early days of the distillery, our company's approach has changed. We were producing more and more gas, which had to be put to use. In addition to the distillery, we installed combined heat and power stations. These produced electricity as well as heat. This heat was used in the biogas plant and also in our residential buildings. When all this was running smoothly, politics were changing, as were the conditions for delivering gas to the grid. For us, that meant the go-ahead. We now simply had to get access to the grid. As cogeneration is only effective as a local source of electricity and heat, and is less efficient when the heat is only used at certain times of the year, upgrading the biogas to biomethane offers better opportunities. Biomethane is a green equivalent to natural gas, as the cycle to produce it is almost climate neutral. Injected into the existing gas network, it brings heating and power to consumers. As a vehicle fuel, it yields a higher kilometer range than any other type of biofuel. In the near future, over 1,000 biogas upgrading plants will start injecting biomethane into the German gas pipeline. By 2020, biomethane is expected to provide 10% of Germany's overall gas demand. By far the biggest advantage is storability. In Germany, the largest energy storage is the natural gas grid. We can store up to 2 months' worth of energy. Of course, what we've stored we can retrieve at any time. Biomethane yields various outputs: car fuel, gas for cooking or heating, or kerosene. For industrial plants needing both heat and power, cogen or steam turbines can be deployed locally. Biomethane offers a twin benefit. First, we gain energy. Secondly, we avoid energy costs. On the one hand, we obtain gas, energy we can use for all sorts of things. On the other hand, the output of a biogas plant can be used as fertilizer. So, this is a typical win-win situation. Energy on the one hand, fertilizer on the other, reducing the burden on the environment. At this site, biogas is upgraded to pipeline quality and purity by the low-pressure CO2 absorption or LP-CoAB process, a registered trademark of Greenmac. It's one of the 2 upgrading technologies available within Greenmac. The first step is removing hydrogen sulfide from the raw biogas, as H2S corrodes pipelines. A blower conveys the gas to a twin-bed H2S filter. Throughout the entire upgrading system, the gas pressure is only a few hundreds of millibars, leading to low energy requirements. The biogas now enters the absorber. As it flows upwards, it encounters the absorbing fluid, which captures the CO2. The amine-based fluid binds chemically to the CO2 without extracting any methane. The saturated fluid exits at the bottom while the clean biogas continues its journey towards the dryer. Here, the water content is removed from the biomethane. Dryer types can be refrigerant, pressure swing adsorption or temperature swing adsorption types. Finally, a biomethane blower slightly increases the pressure of the purified gas. In the stripper, the absorption fluid is regenerated. The CO2 evaporates and is cooled down in the top cooler. Thanks to the high quality of the fluid, the regeneration process consumes little energy, and there is little or no degradation of the fluid over time. To optimize energy efficiency, the temperature difference between the cold CO2 removal process and the high temperature regeneration process is used for heat recovery. In the upgrading process itself, it's used to preheat the fluid before the stripper column. Externally, the recovered heat can be put to use in neighboring on-site processes, heating of greenhouses, etc. The biomethane gas resulting from the LP CoAB process complies with all local environmental regulations. It's a process with very high purity and very low methane losses. Thanks to low gas pressure in the complete system, power consumption is minimal, and heat recovery further contributes to optimal energy efficiency. As a leading equipment supplier, Greenmac helps customers achieve sustainable productivity in biomethane production. Greenmac acquired the know-how of pioneered biogas technology, offering proven high-quality solutions. Installations have been built in Germany, throughout Europe, and there are many more to come. By selecting the most suitable technology for each specific application, optimal energy efficiency and minimal operating costs are achieved. Local service capabilities and remote optimization technology ensure the equipment performs at its best. The iPhone system is proving to be a lifesaver. I always have it with me. It's very reliable, allowing us to monitor the plant continuously. I have all the production steps and parameters at hand. So, I always have a good sense of how the unit is running around the clock. We will surely be able to take more steps to save energy and make the plant even more economical. We are looking forward to these challenges for the future.